Theorem on a dynamical system. Suppose that eigenvalues of a matrix A are real and distinct. So we assume here lambda 1 and lambda 2 are eigenvalues of matrix A with associated eigenvectors are v1 and v2. Then the general solution of the linear system x dash is equal to x is of the form xt alpha e raised to lambda 1 t v1 plus beta e raised to lambda 2 t v2. So to prove this, so what is given here? The given is lambda 1 and lambda 2 are eigenvalues, and the proof of this theorem, we are going to prove this theorem in two parts. First, we are going to show that this xt is the solution of this system x dash is equal to x, and then we are going to show that every solution can be written in this form. Okay, so the part first, say now since lambda 1 and lambda 2 are eigenvalues of matrix A with associated eigenvectors v1 and v2. So this implies, by definition of eigenvalues and eigenvector, we can write A is equal to, we can write here A v1 is equal to lambda 1 v1 and A v2 is equal to lambda 2 v2. Okay, so this is equation number 1. So now we want to show that the xt, now since given xt is equal to alpha e raised to lambda 1 t v1 plus beta e raised to lambda 2 t v2, and we want to show that this is the solution of the system x dash is equal to ax. So consider LHS. So what is LHS here? LHS is equal to x dash t, so which is equal to the derivative of this function. So if you differentiate this function with respect to t, we get alpha e raised to lambda 1 t, and again derivative of this lambda 1 t is lambda 1 v1 plus beta e raised to lambda 2 t, and again derivative of lambda 2 t is lambda 2 v2. Since we know that the derivative of ex is equal to what? Ex, and derivative of e raised to x is what? E raised to x is equal to a e raised to x. So now since by using 1, what is the value of lambda 1 v1 is a v1, and what is the value of lambda 2 v2? It is a v2 by using equation number, this equation. So we can write this x dash t is equal to alpha e raised to lambda 1 t a v1 plus beta e raised to lambda 2 t a v2. So we can take this matrix A outside. So if we take inside the bracket, is alpha e raised to lambda 1 t plus beta e raised to lambda 2 t. But what is this is nothing but the xt. You can check here, this is nothing but the xt. So the value of this bracket is xt, and therefore x dash t is equal to axt, and which is nothing but, so this is nothing but the RHS. So LHS is equal to RHS. This implies xt is equal to alpha e raised to lambda 1 t v1 plus beta e raised to lambda 2 t v2 is solution of solution of the system x dash is equal to ax. So this is the part first. Here we have proved that this xt is solution of the system x dash is equal to ax. Now in part 2 we are going to show that the general solution of the system can be written in this form. Okay, part 2. So uniqueness we are going to show here, that is solution of this system can be written in this form. Okay, So now since let z0 is equal to x0 y0 be any vector, x0 y0 belongs to R square, be any vector, and since and lambda 1 is not equal to lambda 2, lambda 1 is not equal to lambda 2, this implies v1 and v2 linearly independent. These vectors are linearly independent and therefore independent, and this implies there exists scalar alpha and beta such that this z0 can be written as alpha v1 plus beta v2. Okay, and so, alpha v1 plus beta, and therefore from this we can write zt is equal to alpha e raised to lambda 1 t v1 plus beta e raised to lambda 2 t v2 is solution of x dash is equal to x satisfying z0 is equal to z0. Okay, what is this? This is the solution of satisfying the condition is what? Z0 is equal to x0 y0. That is, if we put here t equal to 0, this is nothing but this equation we obtain. Just we write here e raised to, if we write again t equal to 0, you will get the same equation alpha v1 plus beta v2. For example, first we are going to see some examples. Say here, let's consider a matrix. Say how many space. Okay, consider matrix here. I am writing a matrix. Say example, if we consider system x dash is equal to 2 0 0 3 x. Okay, this is a diagonal matrix. Okay, so its eigenvalues are here. Eigenvalues are lambda 1 is equal to 2 and lambda 2 is equal to 3. Eigenvector, since it is a diagonal matrix, a canonical form, so we can write eigenvector is 1 0 and v2 is equal to 0 1. So what is its general solution here? Xt is equal to alpha e raised to 2t 1 0 plus beta e raised to 3t 0 1. So this is the general solution of the system. What is system here? Given dx by dt is equal to twice x and dy by dt is equal to thrice y. So what is here x and y? Here x and y is equal to alpha e raised to 2t alpha e raised to 2t If we simplify this equation, then we get and beta e raised to 3t. So if we simplify these two equations, so this implies x is equal to alpha e raised to 2t and beta is equal to y is equal to beta e raised to 3t. So now these are x and y satisfy this equation. For example, what is dx by dt? Dx by dt is equal to d by dt of x. What is alpha e raised to 2t, which is equal to 2 alpha e raised to 2t, and this is nothing but the twice x. The value of this term is what? Twice x. So dx by dt is equal to twice x. Similarly, dy by dt is equal to d by dt of beta e raised to 3t, and which is nothing but the 3 times beta e raised to 3t, but the value of this term is y, so this is equal to 3y. So this x and y satisfy this system of differential equation, and therefore this is the solution of the given system. Now if we take here say here we take the suppose we take here x0 is equal to, suppose we want to determine a solution satisfying x0 is equal to say 5 6. Then here in place if we put here x0, then we get if we put a t is equal to 0 here, t equal to 0, then we get here, then we get 5 6 is equal to alpha e raised to 0 beta e raised to 0. So this implies alpha is equal to 5 and beta is equal to 6. So this implies, what is your solution? Now if in place, instead of this, we are going to write here xt is equal to, now xt is equal to, what is the value of alpha here? 5 e raised to, see here, 5 e raised to 2t, 5 e raised to 2t 10 plus 6 e raised to 3t 01. So this is what, this is the solution of the given system. X dash is equal to 20 and say 20 and 03, satisfying the condition, and the condition x0 is equal to what? 5 6. Same logic we are going to apply here in this theorem. We consider here one initial condition, z0 is equal to x0 y0. So there exists this is the alpha and beta such that zt is equal to, this is the general solution satisfying z0 is equal to z0. So now suppose there is one more suppose there is one more solution. Suppose there exists one more solution satisfying say z0 equal to z0, say it is what, say y of t, then y of t is the solution of the system y dash t is equal to a y of t. Okay, so okay, such a y of t exists. Okay, suppose we assume here such a y of t exists satisfying this condition z0 equal to z0, and which is the solution of the system a y of t. So now say here, say y of t is equal to phi of t v1 plus psi of t v2. Now this implies y dash t is equal to phi dash t v1 plus psi dash t v2. Okay, now but y dash t is equal to ayt. So this implies, what is y if we substitute y dash t here, what is y dash t? Phi dash t v1 plus psi dash t v2, and what is a times y of t. What is y of t? This is the y of t. See, this is the y of t. Okay, I am highlighting. So here, this is the y of t. What is y of t? Phi of t v1 plus psi of t v2. Okay, so but this is implies phi dash t v1 plus psi dash t v2 is equal to, if we take phi of t outside, it is a v1 plus psi of t outside, then it is what? A v2. But what is the value of a v1? You can check here. What is the value of a v1? A v1 is equal to lambda 1 v1. Why? Lambda 1 is the eigenvalue, and a v2 is what? A v2 is equal to lambda 2 v2. So if we substitute this value here, then we get, then this implies, now this implies phi dash t v1 plus psi dash t v2 is equal to phi of t lambda 1 v1 plus psi of t lambda 2 v2. Now if we equate the LHS and RHS here, if we equate, this is the on this side, this is the coefficient of phi dash t, and this is the coefficient of v1, sorry, coefficient of v1, this is the coefficient of v2, and this is the coefficient of v2. So if we equate, we get phi dash t is equal to phi of t v1 phi of t lambda 1, and psi dash t is equal to psi of t lambda 2. Now okay, so I have a space limited. So now So if we separate the variable here, so we get phi dash t divided by phi of t, phi dash t divided by phi of t is equal to lambda 1, and psi dash t divided by psi of t is equal to lambda 2. Now if we integrate on both sides, since it is a variable separable, if we integrate on both sides, we get here, okay, integrate, then this is equal to log phi of t is equal to lambda 1 t plus say c1, and log psi of t is equal to lambda 2t plus c2. Now the inverse of this implies e and log are the inverses of each other, so this is equal to e raised to lambda 1 t e raised to c1, and psi of t is equal to what? E raised to lambda 2 t e raised to c2. Now this is nothing but, this implies, okay, this implies, now sorry, this implies now okay, now this implies, what is phi of t here? We can write phi of t is equal to alpha e raised to lambda 1 t, and psi of t is equal to beta e raised to lambda 2 t, and therefore what is phi of t and psi of t? So this is what y of t is equal to, we get again y of t is what? Same solution here, and therefore we get y of t is equal to alpha e raised to lambda 1 t v1 plus beta e raised to lambda 2 t v2, and therefore which is nothing but the xt, and therefore y of t is equal to what? Xt, and therefore this solution is what? Unique. What is this? Is here we put here we substitute the value of phi of t and psi of t, and we get y of t is equal to what? Y of t is same as xt, and therefore this solution is what? Unique. You can check here, this is what? Xt. This is the only solution satisfying this condition, x0 is equal to 5 6. There is no other solution satisfying this condition. Okay, so thank you.